and SAS. So I'll start with Hills. Twelfth. No, I'm not at. You guys just want to start answering stuff. I haven't even said a word. The H, hypotenuse. L, Emma, leg. Other L, same leg, and S, segment next to the leg I am working with. Perfect. And then finally, SAS, explain to me how that one works. 20, the S, segment A, same altitude, there's only one, and then other segment, two different segments. All right, we ready? It's going to be difficult today. Here's why it's going to be difficult. I'll just prepare you right now. First reason it's going to be difficult, you don't know where to start because now we're going to have three variables to solve for. Second reason it's going to be difficult, you're going to have to factor or use quadratic formula when you solve your proportions. Okay? So let's do this. Let's get over it and let's go. Look at number one, X, Y, Z. Woo! All right. Well, we got to pick one first to solve. And I do not want a proportion with two variables in it. If you set up a proportion, make sure it's got one and only one variable. What's the Y acting as on there? That's my altitude. So if I wanted to solve for Y right now, I'd have to use what? SAS. And watch what happens when I use SAS. Everyone ready? Give me a segment. Okay, 1 over Y equals Y over, what's the other segment? Okay, that's not going to work. Not going to solve a proportion with Y and X in it. So Y is out of the question. All right. Hi, Sean.
Could you use Pythagorean theorem to solve for Y?
You want just stealing my fire today? Just stealing my fire. All right. My next point was going to be, and we never brought this up yesterday because we didn't need it, was you guys are just so driven right now to, it's got to be Hills, got to be SAS, got to be Hills, got to be SAS. But you have to remember, you have three what type of triangles here? Right triangles. And you always have what in your back pocket if you have right triangles? Pythag. Okay? Don't forget about Pythag. Don't automatically assume Hills, SAS, Hills, SAS, Hills, SAS, Hills, SAS. No, you can use Pythag. Does everyone see that I can use Pythag on this triangle on the left to solve for Y? Okay, let's do it then. How's that going to look? So we're going to solve for Y first. How's Pythag going to look? What are the two legs and the hypotenuse there? Here we go, 12. Okay, so Y squared plus 1 squared equals 3 squared. Got it? Y squared plus 1 equals 9. Yep, move the 1 over. Y squared equals 8. And you know what I'm going to ask here? Yep, simplest radical form. I think we broke down 8 yesterday. What's it break down into? Here you go. 7, what's it break down into? Yep, so keep going. There's Y. What do you want to go for next now? Hills, SAS, Pythag, they're all available here. Maybe not Pythag anymore, but anybody have a variable they think they can find? Mike? X, yeah, let's go find X right now. What do we call X, by the way, in this diagram? Don't yell anything out. What do we call it? I labeled it earlier. 9, what do we call X? Segment. So, I could use SAS or Hills, but
Oh, you're still asking me?
Sure. Sorry, Justin.
Oh, we're going to be doing hills.
Okay, so you want to use hills?
Yes.
Okay. You went the challenging way, but that's fine. Kid wants to use hills. Let's go, guys. Anybody want it? You could have used SAS as well, right? Okay, but let's use hills. Good. I like it. You're challenging your classmates. Hypotenuse length. Ooh, be careful here. 18. What's the hypotenuse length? What is it? X plus 1. Good man. I need a leg now, but I don't want two different variables. There's a hint of what leg I want now. All right? I need a leg, but I don't want two different variables in the proportion. So what leg you going to give me? Here you go. 1, not here. I already know. 18. 3. What do you know about that leg, Hugh? Oh, he's giving me the segment too. Okay, yes, the segment would be 1 because it's adjacent to it. Bunch of tough guys in here. Everyone all right on the setup? And yes, could you have used SAS too? Fine. You're still going to get the same result we do right now, which is x plus 1 equals 9. So x equals 8. And then we go to z. Really, the only thing we can't use to find z, because it's a leg, would be SAS. Okay, there's no reason to use SAS because it doesn't involve a leg, but whoever comes up here, I'll let you decide what you want to do. 16. What do you want to do to find z? All right, Pythagorean theorem. You have even another decision to make, though, Maggie, because I can do the Pythagorean theorem on the large triangle, or I can do it on the triangle on the right, which contains z as well. Okay, she's going smaller one, everybody. Okay? Don't shake your head or groan or sigh. Do it every way you want and see if we come up with the answer at the end. Okay? All right, Maggie, ready? So on the small one, my two legs are 8. And I'm glad you picked that one. Plus, what's the other leg? Okay, hey, everybody. And this is, no matter if you're doing it this way or not, focus in here for a second. You can't plug that in your calculator like that. What are you squaring there? Your calculator's only going to square the radical 2. You want to square the entire thing. So make sure if you use your calculator here, it goes in parentheses. Equals z squared. Okay? So what do I have? 64 plus, anybody finding that if you're doing it this way anyway? Should be what, 8? You guys that are squaring 2 radical 2 in your calculator? 8. Make sure it's in parentheses. Okay, square the whole thing, not just the radical 2. So 8. And then z squared equals 72. And yes, you are going to break down 72 for me. I'll let you figure that one out. I'll ask somebody. Biggest perfect square. 9's not the first. 9's not the biggest. Little FYI for you. 9's not the biggest. $72, breaking down. 16 again. 6 radical 2. So really, no matter how you did find z, I'm hoping 6 radical 2 was the answer. Whether you use hills, whether you use Pythag like we did, or Pythag on the large right triangle. Whew, a little tougher now, huh? Got to take our time. What's going to work? What's not going to work? All right, one doesn't make you great, though. Let's keep going. Whew. Solve for x and y. Everyone like my hint? Think about old stuff to get started. What do I mean? Like expired food? Senior citizens? What do I mean? Was that too bad? Too rough? Sorry. What a hint. Think about old stuff to get started. Well, I see that I'm trying to find the segments and no altitude. So SAS is out, so I automatically think hills. But if I try hills right now, I'm going to say the hypotenuse is x plus y, no good. But I still want to use hills. Don't put x plus y. Can you actually find that hypotenuse? Always have what in your back pocket? Right? Here's the right triangle. Yeah, there's the right triangle. You already know two sides. Find the third. All right. Yes? Okay, let's do it. So you got, let's see, what are the 15 and the 20? Are those legs, hypotenuse and a leg? 15 squared plus 20 squared equals c squared. I'm going to put h squared for the old hypotenuse. Always remember Pythag. Hypotenuse length, whenever you're ready. 2, whenever you're ready.
25.
Thank you. 25 is the length of the hypotenuse. So 25 for hypotenuse. Give me a leg. It's your choice. Your choice. 1. See ya. 19. Your choice. A leg. 15. Sure. 15. Legs are the same in hills. If we pick 15, what segment are we going to solve for then? What segment are we solving for? 16. What segment? X. There we go. Nice. Is that 225? All right, how many quarters are in $2.25? 9 quarters. Hey, enriched kids, I really don't want to do hills again. To find y, is there a really quick way, Emily? Yeah, the whole hypotenuse is 25, we found out, minus the 9 I found for x. So, yep, 16 for y. You can do hills again if you want, but get there a little quicker. And yes, if you're wondering, I know you were, we can do word problems with hills and SAS. Yes. Yes. I could not get them on the diagram for some reason, so can you add them in that these are right angles here? Okay, I couldn't put them in the diagram for some reason, but. Are we ready to read this bad boy? A photographer wants to take a picture of the beach. His camera has a viewing angle of 90 degrees. Whew. And he wants to make sure those 2 palm trees at A and B are in there. How far on the walkway does he have to walk out so he gets that 90-degree shot? So he's got his little... just embarrassing myself. It's fine. Palm tree, everybody good? Right? The wind's blowing this way, I think, so that's what's happening. There's our palm trees. How far down the walkway does he have to walk out? All right. Does everyone see a right triangle with an altitude drawn on the hypotenuse? What's the walkway acting as? The altitude, yep. So this is going to be a, yep. Regents love to put the hill SAS as a word problem. All right, give me your segments and your altitude. Let's roll. 9, let's roll. 40.
90. Or no, you meant that one. It's going to be X.
Other altitude.
X.
Thank you. And how far does he have to walk out to get that 90-degree shot? $60. Yes, if you're I know we haven't really had an opportunity to talk about it, but if your problem has units, so does your answer, please. All right. 60 feet out on the walkway for the photographer. Or 20 yards, yes. Anybody else want to do some metric conversions there? Okay, here we go. I talked about factoring in the quadratic formula. Here we go. This one's not bad at all to set up, maybe to solve, though, for some of you. Okay, first I need to know, Hills or SAS, what's appropriate? What's going to be appropriate here? 18, what's going to be appropriate? Because I give him the altitude. All right, so here we go. Match it up. Fill it in for me. Here we go. 9, fill it in.
10. Or no, never mind. I flipped them. X plus 15.
You could do that. You could do 10 over x plus 15 equals x over 10. You know, it's still the same proportion, but x plus 15 over
10
equals
x over 10. Or no, 10 over x.
You all right? You're rattled, bud. Rattled. We're in his head now. Random generator knows it too, Justin. He's going to come back. It's going to come back to you. Okay, cross multiply. Here we go. What do we end up with when I cross multiply? 10.
Oh, when you cross multiply.
Yep.
X squared plus 15x equals 100.
All right. We've been down this road a lot last unit. Been down this road a lot. I got an x squared thinking about factoring or quadratic formula, but before I do either, 17, what's got to happen? Yep. So x squared plus 15x minus 100 equals 0. Again, now this is where you and I may differ. If tonight on homework you want to do quadratic formula, fine. For time's sake and because we're enriched here, I am going to factor it. Two numbers that multiply to what? 100 and add to 15. So let's start. Don't yell anything out. Let's start thinking about numbers now. Multiply to 100. 10 and 10. Am I going to get a 15 from 10 and 10? No. 25 and 4. Nope. I'm just stalling because I know the answer. I'm not going to say until last. How about 1 and 100? 2 and 50. There's only one combo I have not gone over. 20 and 5. What about the signs, though, to get positive 15 from a 20 and a 5? Let's solve. X equals 5. X equals negative 20. Hello, anybody? Anybody want to talk to me?
I do.
What about what? There is a diagram, so what can I not have? And does one of these answers lead to a negative side length?
Yeah.
Which one, Will? See ya. I didn't need backup there, but thanks. X equals 5. You guys are responsible for the next one in your groups, and we'll go over it as a class in about 3 minutes. Okay, ready? Here you go. Everyone ready to get it going? Because I saw a wide variety of answers here. Okay, first thing is people were saying, oh, I got the altitude, so I want to use SAS. No problem. So you said segment is X, altitude's 12, 12, and then we got to the other segment, which, good job, most of you here. 26 is the whole hypotenuse. That segment's X, so that's got to be 26 minus X. We put it in. Cross multiplying, you get 26x minus x squared equals 144. This is just a me thing, but I don't like x squareds to be negative, especially if I'm about to factor. So I'm going to move everything over to the right, excuse me. So I'm going to have that positive x squared with a negative 26x plus 144. If you use quadratic formula, it doesn't matter if your x squared is negative or not. It just affects your a value. And then I factored this into x minus 18 and x minus 8. So I ended up with x equals 8, and quadratic formula would have gave you the same values, 8 and 18. Now, if I plug either one in, is that going to give me a negative side length? No, I know this is rare for us, but I will accept both side lengths. It could be 18 or it could be 8. All right, questions? Okay, go ahead, get started. Take your time.